its system. Quad, not quadratic functions, and hello, am I audible? Okay, so yeah, some people are asking about the okay, the recording. Yeah, this is live. This session is going live. So already it is streaming on YouTube. So and you can get the link of this YouTube is BS degree channel. It is already. Let me. I will show you on itself. Okay, I will show you the link right here. So just a minute. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
And recording. Thanks. Yeah, so streaming is on BS degree channel. All of you can get from there. So just a minute. How we so in this session? So last time you studied about the polynomials also. The remaining thing is quadratic functions and then polynomials and logarithmic and exponential functions and some bit information about the graph theory. So that session is the previous session were for who is going to appear for the diploma entry exam and in the programming only. This session is for who is going to appear the diploma entry for the data science. So in this session, we are going to discuss the calculus portion for function of one variable and graph theory, some deep, not much deep. I will see longest path and uh, DFS, BFS is there, depth first search and breadth first search, and some algorithms are there for to find the shortest path. And there is one uh, algorithm which is called Prim's algorithm and Kruskal algorithm to find the cost of minimum spanning tree. So we'll see that. Okay, so let me present my screen. Just a minute. Am I audible? No one is speaking.
You're audible, sir. So,
So usually these many people are the people who actually attend the class.
my screen is visible to all of you, right?
Yes, sir.
Okay, so let's start the session. So in this session, we are going to discuss. Let me write down the. Let me write down the topics which are I'm going to discuss here. So the first topic is we will start from the calculus. We will see sequence, and then we will see limit of sequence. So that is in the first part. It is limit of sequence, and we'll see there some example also. I have some older QP. We'll see there, and the second thing is the limit of function. Third is continuity. Fourth is differentiability. Fifth is integration. And sixth is the critical point maxima minima. And seventh is now we will move on to graph theory. So there we will see vertices, edges, and graph theory. In graph theory, we will see adjacency matrix. And about the graph we will see, and there is a graph coloring. Okay, and independence that is there. And fourth is this three is only enough. Vertex cover is there. And fifth is about the BFS. DFS is there. Two things we have: depth first search and depth first search. And another thing is longest path along with topological sorting. Okay, seventh is there is one this is longest path, and there is a MCST, minimum cost spanning tree, using the Prim's algorithm and Kruskal. Am I audible right now?
Yes, sir.
yes, sir.
Yes, sir.
So first thing, please let me know. So these are topics we are going to cover. And please let me know, anyone have doubts first? Whatever the doubts you have, you can tell me, so that I can clear your doubts, and then we'll start these things. Okay. So anyone have doubt something, any kind of doubt, you can ask. And about the QPs, like how the QPs will be. So let me show you the older QP which we have. This is the DAD for data science, diploma entry for data science. So we have some questions like finding the maxima minima of some functions we have. And here is the regarding the polynomials. And this problem is for the quadratic. This is on the coordinate. Okay, we'll try to solve some problem. This is for the sequences. This is for the limit of the, so we'll see, we'll try to solve some problem. Okay.
Sir, can you share this question paper at the end?
Okay, so yeah, I will share to now itself. So just a minute. In the last also I will share, and here now itself I will share. So just a minute. Okay.
So, I have a question from one of
Yeah, what?
the sample papers that we got.
Okay.
It was the second NAT question, and I think this is for the math for programming. It was the number of solutions in an interval 2 to infinity, and the equation was log of a polynomial, 4-degree polynomial.
Okay.
Do you have the question, or do you want me to send a photo of it, sir?
Can you tell me the problem, because I don't know which question number you are saying, which question you are saying.
It's question number 2 in the NAT section. It was one of the mock tests that we got in the document, in the PDF document.
Okay.
I can send a screenshot of the question if you want.
You can tell me the question itself. Just a minute. Let me give this. I want to give the slide of this. Just a minute.
Sure.
No, the older QP means I want to give you the older QP.
Sure. No.
So I'm posting the link of this QP here itself for everyone. So all of you, please, you can download this QP. Let me present my screen now. Okay. So we have okay, find the number of solution in the interval this. We
Yes,
have
yes.
note need to check the domain. Okay. Int the diesel y. So yeah, so you have to just no need to check the domain of this log. Okay, just you have it is the first thing is given. This one is divisible by this one. So find the number of solution for this is what is going to be this one. So you can see this is what is going to be this. This means this is log equal to 0. So what it mean that this is going to be equal to 1, right? This is
Yes,
going to
sir.
be equal to 1. So equal to 1 means now you can send this side easily and so are you getting no then it is equal to 1 means now the finally the what is going to be the polynomial this is and in the last this side if you say this becomes 16. So finally you will get this polynomial, right? This one, this polynomial you will get.
Okay.
Okay,
Which
once
polynomial?
you get this polynomial you need to factorize it and need to find the solution. And
Of the
how to
poly-
factorize it is given that it is this polynomial is divisible by this polynomial itself.
Okay.
If you divide this polynomial by this polynomial, so you will get another factor that is of the degree 2 also. And degree 2 polynomial, this you can easily factorize, right? What is the
Yeah.
factorize? You can
I haven't.
factorize that easily.
Mhm.
This is a quadratic function. And once you divide that, you will get the another polynomial, so another quadratic function. You can that also you can also that factorize. You can factorize that. No, are you getting what I'm saying?
I'm getting what you're saying, so I just don't know what to do with the log at the end. Like,
So in the not log. So what I'm saying, whatever you have this one, no, whatever the log and inside the polynomial, whatever in the log you have this polynomial. This
yes.
polynomial is going to be equal to 1, and that side is you can
When you
send
get the
one
log,
this side is so this polynomial equal to 0. Now you
okay.
have to factorize. So what is that polynomial? That polynomial is nothing but this polynomial, x to the
Yes.
power 4, and you have to factorize it. That's all.
Factorize x to the power 2. That's it.
And
That's it.
factorizing means it is a one already given, then this is divisible by this. So that means this is one factor of this polynomial.
Okay. And
Correct?
in the paper, will you get hints like this, or is it just for the mock paper? I mean, this is one of the past papers, right?
So this is one of the past papers. So yeah, whatever is here is similar kind of you will get that.
Okay. Never mind. Thank you, sir.
Okay, so let's discuss this one now. The limit of sequence. So
Sir?
yes,
Sir, I also have one doubt from sample paper.
sorry. You
Sir,
have
I also have doubt in one of the question in sample paper. Should I
okay.
share the screenshot?
Yes, you can share. And also, all of you are here for to give the diploma for data science or programming also.
Programming also, sir.
Okay, so
I think the graph theory is
Sir,
very important for programming, so because in the last session we did a little bit, but the
can you
topological
please
thought.
share the programming qualifier if possible?
okay, so programming qualifier is also now I can itself share here. Okay, just a minute. Again, I'm just stopping and I will share you the link of the like just now I said. So all of you please go through the chat. I have shared the older QP for data science. Okay, so
Yes, sir.
so let me share you the qualifier QP for programming also. Because okay, this is again, I'm sharing this PDF, which is a qualifier exam for program. Okay, let me again share my screen. Okay. So just when somebody have posted a problem in chat. So what is the problem in this problem? Okay, draw Rangoli in, of course, he has zigzag lines. He started. Okay, one there's something bigger thing is there. But what is the final thing is asking about then what should be the minimum length of the floor in the direction of a DR. Okay. We will say okay. Okay, we have shared this. We'll discuss. Okay, just a minute. It will take time to understand the first question. So let me finish that what I want to finish. Okay, then we can discuss. I hope it is fine for you, right?
Okay, sir. Okay, no problem, sir.
What I want to discuss here. Let me finish this one. Whatever I just wrote, then I can discuss your question. Okay.
Okay, sir.
Okay, so we'll discuss the limit of a sequence. So before to think about limit of a sequence, so who is here for programming only? So this problem, this whatever this is here, this is not going to whatever the topics here I just wrote, this questions will not going to come in the programming qualifier exam. Okay, so this is for only data science. So please make clear. That's why the sessions is also kept like that. The first session is for the programming. So syllabus is also related. Syllabus were also related with that 1 to 6. Sorry, functions and quadratic functions, coordinate system, polynomials, and that logarithmic exponential and bit information about the vertex cover. And the bit information about the minimum vertex cover and adjacency matrix. That's all. And minimum, yeah, that's all. So these are the topics will come in the programming. So who is here? Whatever I am going to discuss, the topics which I know wrote here, that is not come in the programming exam. So who wants to leave can leave for the programming, and who is going to give the programming can leave. And also I have shared the QP, so please see that. And whatever you have the group related to that, you can share in that QPs, older QPs. Okay. So limit of sequence. So before to start limit of sequence, first thing, what is the sequence? So in the brief, just a minute. Okay, so first thing is let me start the sequences. So sequences is nothing but am I audible right now?
Yes, sir.
Yes, sir.
Okay, so sequences is nothing but a function. So function, this is a function. So function, we know last time we have seen the function. Function is nothing but a expression, you can think. Okay, but expression is meant to say it should have for one input, it cannot give two output. For one input, it give the single output. Will not like that. The function is nothing but the like this. Suppose uh, suppose here the some elements and here some elements. This is called the domain set. These are our input set, you can say, and this is the output set. The expression means here suppose fx is equal to 2x square plus 5. So suppose this is an expression. No? This is an expression in the variable. This is a kind of this is I mean to say you are going to give some input. Here is any number is going to take. So you can think think this is the set. The input set is there. So this is the function you have. So but the expression, the condition for this expression is that it cannot be like this. So for the single input, you cannot get the two different output. Yeah, this is the possibility that this could be possible, but not the previous one. So this is a function. So sequence is also a function, but here, so this expression, if you think this function is, you can give any real number here. Input is in any real number you can give. But for the sequences, the input set is only the natural number. Only the natural number you can think here. So like the sequences is like here is for any real number. So sequences is you can change, this is for any real number. So you can change x with n. So that means this is going to be fn. So this is 2n plus 5. So that means here n means you can give the input from the natural number. So natural number is a counting number. You can think it started from 1, 2, 3. Okay. This is going to be your natural number. So natural number is also in different word called counting number. So this is a now a sequence. So this function is actually a kind of, so this is we are going to study on the whole real number, but here is we are studying only the natural number. So sequence is nothing but the function, but the domain of the function is the natural number. Okay. So this is one part. So there is a limit thing, limit of a sequence. Okay. So limit of a sequence means, for example, here is what is going to be happen with the this sequence once you or what is going to be the output. So here is this function is the input is the natural number and output is the any real number is here. You can any not any real number, the output is the real number. So what will happen once you give the input very large natural number, means the counting number means 1,000, million, billion, trillion, whatever you will give what output. So here is the condition that once you are giving the output, sorry, input some very, is there any real number around that the output is coming? For example, I am saying,
Sir, your voice is breaking.
suppose
voice
I
is
am
not
taking
clear.
sequence fn, or in different word it is generally written as I'm
Sir,
just taking
your voice
1
is
plus
not
1 by
audible,
n.
sir.
Okay, 1 plus 1 by n. So am I audible right now? I just got disconnected. I don't know why. Okay, so let me again share my screen. Okay. So I was discussing about the sequences here. So till whatever I discussed here, is that clear? This one or this one?
So from limit of sequence, we weren't able to hear you properly.
Sorry.
When you started explaining the limit of sequence, your voice dropped out many times. We weren't able to hear you properly.
Okay.
from limit.
Yeah, so please let me, if my voice is not clear, please let me know so that I know all of you are not listening that or that there is a glitch or my voice is not clear. So please let me know, please stop me so that I could repeat. Okay. So here is the limit of sequences. Here is, suppose this is a sequence you have. So what will happen with this number once you give, or what is going to be the output once you give the very large input? Like for this one, suppose you have this sequence. So if you give the input very large number here, what is going to be the output? Or let's say I am saying n is equal to 1000. Okay, what is going to be the output? 1 plus 1 upon 1000. So is this number is very near to 1, right? Am I audible?
Yes, sir. Yes, sir.
So this number is, whatever this number you will get, this number is very close to 1. So this is, you can say this is the mean. Now this is 1000, no? If you give very large number, 1 billion, trillion, whatever the number you will give, that number is, once you give the input, that the output is actually come out very close to some real number. Like here, what is happening? It is coming to close to 1. Still, if you give very large number, still this the output is actually come around the 1. Around the 1 only on the real line. Here is suppose 1. So input you are giving the very large number, output is coming, will come here. Suppose here is 1. So out will come around this, around the 1. Around the 1 it will come. So this 1 is actually called the limit of the sequence. So in the notation form, it's generally written as the limit as n goes to infinity. This means that this notation is actually tells you are giving input very large number, but it is not clear what is the exact large number, but it says that you are giving the input in very large number. Okay. So limit of this sequence is now going to be as 1. In the notation format, it is written as 1. So this is called the limit of a sequence. Okay. Now, like now I'm just giving an example. So there are some sequences which don't have the limit. So for example, I'm just giving sequence n square plus 2n plus 1 upon n square plus 3n plus 5. What is going to be the limit for this sequence? Anyone?
Infinity.
Sorry, what? Sorry. Sorry.
Infinity.
One.
Sir, it is infinity by infinity form. So we use L'Hospital's rules, I think.
Sir dropped out, I guess. He's done.
No, it is a infinite by infinite. So to deal this problem, what we can do, we have to do something. We have to think it. So somebody says the limit is going to be 1. So can you tell me why it is 1?
Sir, by the L'Hospital rule.
So L'Hospital rule is generally will not work for the sequences, no? L'Hospital rule is L'Hospital rule is for the functions only.
Sir, but if you divide the whole term to n square, like n square plus 2n plus 1, divided by n square, and similar with the denominator term also, then it will be like 1 plus 2 upon n plus 1 upon n square. And similarly in the denominator, 1 plus 3 upon n plus 5 upon n square.
Yeah, so that's the one thing. That's the one thing. So you
Yes.
can take n square common, or you can divide both numerator and denominator by n square. So you will get here 1 plus 2 by n plus 1 by n square, and this is 1 plus 3 by n and 5 by n square. And once you take the limit here, okay. Now if you take the limit, so limit of the sequence 1 by n square or limit of 1 by n. So what is the limit of this sequence
Zero.
Again, yeah, the same process. You can think that if you give here very large number, the output what will going to be 1 upon in very large number. That means it will close to 0. So that means finally you can say the limit is going to be 0. This one is also going to 0. So once you take the limit here, this will go to 0. 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 So finally the limit is going to be 1 by 1, which is 1. Okay, so by this way you can find the limit of sequences. Now, once you know the limit of sequence, so can you tell me the another sequence minus 1 by n? What is going to be the limit for this sequence, or limit will exist? But the first thing is limit will exist or not? Can you tell me? Limit will going to be exist or not? Can you try once? What will happen when you give a very large number?
Infinity.
No. Why it is going to be infinite? If you give like if you give n is equal to 5, then it will become minus 1 to the power 5.
1, sir.
So either +1 or -1 then.
So this is, if you think that this is, if you minus 1 to the power 5, you will get this is going to be -1, and if you give minus 1 to the power, if you give any even number, so let's suppose this is 4, this is going to be what? 1. So there is a case is happening that if you give the even number, very large even number, so it will give, then it will give 1, and if we give odd, very large odd number, still it will give 1. So what is happening with this sequences is it is actually oscillating, means sometime it will give 1, sometime it will go -1. If you give any large number, so we don't know what will happen, then you can say that it is the output is actually coming either 1 or -1, 1 or -1. So such type of sequence is actually not converging. Okay, so this sequence is actually not converging. There is no limit for this sequence. Limit does not exist. Okay. Another example, suppose you have a sequence 2n plus 5. Okay. So what about this sequence? It will converge. Converge means you will get the limit. Oscillate means you will get some real number, but it will oscillate means here sometime it will get 1, or sometime it will give -1. Similarly for others also could be. For this sequence, what is going to be the limit, or will the limit exist or not?
But doesn't exist.
Again, sorry.
Sir, limit doesn't exist.
So here is limit does not exist. The reason is if you give very large number, it will go to give also very large number. So here it means if you take the limit as n goes to infinity, fn is give the infinite. So such type of sequence is called divergent. Okay. So these are the types of sequences: convergent, divergent, and oscillate. And the limit is nothing but or converging sequence or limit. Converging sequence have the limit. So if a limit is exists, you can say the sequence is convergent. So this is all about the sequences. And now the limit of function we have. Okay. Limit of function. So limit of function means, again, the concept, what is the meaning of the limit of a function means, suppose I am just writing this kind of x square plus 1, and this is x square, or x square minus 1 and x plus 1. So what is going to be, here is a limit of, so limit of a function. So first thing, what is the limit of a function? So again, suppose you have a sequence, or suppose you have a function fx. Okay, suppose you have a function fx, is I'm just writing like this. So suppose I'm just writing this function x square minus 1 upon x plus 1. So if you check that at x is equal to minus 1, it will, this function is not defined. In numerator, sorry, in denominator, you will get 0. And so at minus 1, the function is not defined. So you don't have the function value at minus 1. So what will happen when the function is, suppose here is, suppose I don't know what is going to be the graph here. Suppose here is minus 1, and suppose is the graph is like this. So what will happen? Okay, here is minus 1. Here is minus 1. So what will happen around minus 1? Once you give the input, what is going to be the output? We don't know here, the function is not defined, but around, what is around, if you give the input around minus 1, okay, which is close to minus 1, what is going to be the output here? Is there any real number, or the output will exist? Is that any real number around that you will get the output? So that is called that real number is actually called the limit of the function. So like here, we want to find the limit of this function. So how we can find the limit? So it is generally written as the limit as, x goes to minus 1. This is x square minus 1 upon x plus 1. So suppose this is the function you have, and you want to find the limit of this function. So this means you are giving the input around minus 1, and what is going to be the output? What is going to be the output? Is there any real number around that you will get the output? That is the meaning of the limit of a function. So how we will solve this problem? Anyone? Am I audible?
Yes, sir.
So to solve this problem, see, we have this function, no? So please let me know, please stop me if you are not getting. Till now, whatever we discussed, all of you got that, or I don't know. All of you are getting that what I am discussing?
Yes, sir.
Yes, sir.
Okay, so actually these topics will come in the exam, no? So some question will be finding the limit of sequence. Some question will be finding the limit of function, and a direct question you will see. That's why I'm just writing directly the question. Like here, what is going to be the limit of this function? Similar question you can get here. So what is going to be the limit here? So you have this function, no? This in numerator you have this x square minus 1. So this you can write, okay, x square minus 1. Here is 1 to the power square also, 1 to the power 2 also. This could be written as x minus 1 and x plus 1, as a square minus b square is nothing but a plus b and a minus b. Now you can cancel out these two. X plus 1 is here and x plus 1 is here. So as now finally, what is going to be that with this is limit as x goes to minus 1. This is finally will get x minus 1. That's all. These two are cancelled out. So this could be written as minus 1, minus 1. Just substitution. Just do the substitution here. You will substitute here now. X minus 1 in place of x, you will substitute here minus 1, minus 1, minus 1. It will become minus. So limit of this function is going to be minus 1. So what it means that you are giving the inputs around this minus 1, you will get the output around minus 2 here. So here is going to be the graph, not this side. In the below side it will be. So around this minus 2, you will get the output. So we are actually getting a number, real number. Around that you will get the output if you give the input around minus 1. This is the mean of the limit of this function. Okay, so this is one limit of a function, and I'm just giving another example. So suppose I'm just asking as limit x goes to infinite, what is going to be the x square plus 5x, or let me write it is here, 5x to the power 4 plus 2x square plus 1 upon 6x to the power 4 plus 7x square plus 1. What is going to be the limit of this function as the x goes to infinity?
Five by six.
Yeah, this is a very similar to the sequence like this. This is a very similar to the sequence thing. So I did this problem for the finite sequence. It is approaching to the finite number, but this is for the infinite. This is called the finding the sequence at the infinite. This is another thing. This is another. So to solve this problem means here is again, if you take numerator and denominator, if you divide numerator and denominator with the x to the power 4, that means you will get 5 plus 2x square will cancel out here, or 2 upon x square minus 1 upon x to the power 4. And this could be 6 plus 7 by x square plus 1 upon x to the power 4. Okay. Suppose you have this one now. So as limit x goes to infinite, 1 by x or 1 by x square is again that you will get, that means here you are giving the input very large number, so output will be, it will close to 0. The number will be very close to 0. That means it is actually approaching to 0. So this will approach to 0, this will approach to 0, this will approach to 0, this will approach to 0. So finally limit is going to be 5 by 6. So there is another method also to finding the limit is L'Hopital rule. Okay, suppose you have a function, I am just writing like this, the same previous one, x square minus 1 upon x plus 1, or let me write here x minus 1. Okay, I'm differently, I just wrote here. So, and what is going to be the limit of this sequence, this function as x goes to 1. So if you see that, if you substitute here 1, you will get 0 by 0 form, right? It is kind of 0 by 0 form. So suppose you have a function written as in the fashion of this in fraction form. Function is in this fashion, it is written, and the form is, once you substitute the value in this function, you will get 0 by 0 form, or infinite by infinite form, or minus infinite by minus infinite form. Okay. In this three type, it is the function is happening. So in that case, what is going to be the limit of this is, once we know the derivative, now all of you are going to discuss giving the derivative or that for data science. Hope you know what is the derivative. So derivative means you just differentiate this function. So if you differentiate this function, this will become 2x. Okay, and in numerator it will become 2x, and in denominator it will become 1. Okay, so now finally, to find this limit is exactly finding this limit. And what is going to be the limit here now? Just substitute here, which is going to be 2. So this is called applying the L'Hopital rule or L'Hospital rule. There are many different pronunciation. I generally say L'Hopital, somebody says L'Hospital rule. So this is the L'Hopital rule. Means here if your function is forming in this fashion, then just derivate your numerator and denominator separately. Okay, and then find the limit of the derivated function. Okay. Is that clear? This is called
I have a doubt.
Okay, what's your doubt?
Sir, what if
voice is not coming.
numerator? Sir,
Sorry,
what if
my voice is,
numerator and oh, sorry.
my voice is clear now?
Yes, sir.
Okay.
Yes, sir.
So
Okay.
what if
So what you are
numerator
saying?
and denominator? What if numerator and denominator don't have anything in common? Like in the example, if x square minus 1 divided by x and limit x tend to 0. So how will
So
we
in
solve
that
that?
case, so yeah, suppose you have this one, x square minus 1 upon x. Okay, and limit x goes to 0. Okay, so this is not forming in the form of this one. It is not forming. This is 1 minus 0 by form. So it is not in this form. So we cannot use the L'Hopital rule. We cannot use this one. So then how we can do? So for that, so we have to check that, right? So again, this is going to be what you have to divide this. No? So you have to do some manipulation. Like what you can do it here. This is going to be x square upon x minus 1 by x kind of thing. So this is going to be x minus 1 by x kind of thing. Now, if you want to find the limit as x goes to 0, this limit is for the, like if you have two function fx plus gx, so you can do separately here. So you can find this limit, this is going to be 0, but you cannot find the limit. You are unable to find the limit of this one. Correct? So in this fashion, you can say directly say the limit is not exist.
And sir, the
Okay.
L hospital rule only follows for the following, like 0 by 0, infinity by infinity, and minus infinity by infinity.
Yeah, in that case is only possible.
Okay.
Okay. Okay. Now, continuity. Let's come to the continuity. What is continuity? Continuity of the function is, suppose I'm just showing you with the graph. Okay, suppose I'm just drawing a graph. Okay, with so I'm just drawing a graph of function. So see that this graph is smoothly going. I just took my pen here and starting moving, and there is no break or there is no jump is happening. Suppose I am trying to draw the graph of a function, but what is happening once you try to go, I got there is a jump and then again like this. So this is a break is happening. So this is such kind of thing is called discontinuity, or the function is not continuous. So for example, I am saying, suppose you have a function fx is, suppose this fashion, greatest integer, or all of you know the floor function, no? Floor function. Floor function. Floor function is what? Suppose here is, if you give 1.2, if you give x value is 1.2, so this the floor value is going to be this function value is going to be 1. So this is a kind of floor function. So if you draw the graph of the floor function, it will look like this. 0 to 1, it will be like this, and 1 to 2, it will be like this, and so each time there will be a jump. So this is 2 here, this is 3 here, this is 4 here. So these are the jump is going to be. So see that at 2 there is a jump is happening. At 3 there is a jump is happening. So such type of function is called not discontinuous function. So there is a condition that a function is will be continuous or not. So if the limit as x goes to a fx, this is equal to going to be this function value at, then function is called continuous. Then function is going to be continuous. Okay. For example, if it is not such thing is happening, then your function is not going to be continuous. For example, suppose I am writing fx. Fx is equal to, let's say 1 by x when x is not equal to 0, and x is equal to, when x is equal to 0, the function value is 1. Or let me tell you that differently also, or here is or the same here, no, x square minus 1 upon x square x minus 1. Yeah, this one. Suppose your function is this one. When x is not equal to here is not going to be 0, here is going to be not equal to 1, and here is once you have equal to 1, then function value is this one. If x is not equal to 1, this is the function we have here, and if it is equal to 1, this is the. If you find the limit, so we got the limit here for this one. No? We got the limit at 1 is limit as x goes to 1. This function limit is what? Can you tell me? We just now calculated. What is the limit as x goes to 1?
2.
2. Using the L'Hopital rule, we can write, easily can find. So this limit is going to be as x goes to infinity or x goes to 1. This limit is going to be 2. So see that. So what is happening here? Limit as x goes to 1, fx is 2. But this is not equal to the function value at 1. The function value at 1 is what? See that 1 is there. So function is not continuous here at. Okay. So this is called this is the condition of the continuity. So this is all about the continuity of a function. Now there is another thing is called differentiability, differentiation. Differentiability of function. So once you have a continuous function, so we can think differentiability. So what is the differentiability? So what is the differentiability? So suppose if you have a function, no, suppose I'm just writing this, suppose I'm driving this graph. Okay. Suppose I am drawing this graph. Okay. And what is happening here?
So you are not audible.
Okay, so suppose you have a graph, suppose you have a function, okay, this one. And what will happen? Suppose this is the input you have. So I'm just telling about the differentiability of a function. So what is the difference mean? Here is suppose A, okay. So what is happening here? I got the output is f of it. Suppose this is a graph of function f is this one. And I just a small expansion I did, okay, here is. And a small expansion means here is I just added a small number, h positive number, and I also subtracted from A, I just subtracted -1. So this is going to be A plus h and this is going to be A minus h. So corresponding output is going to be this one, right? Okay. So just think about this one. So this is going to be f of A plus h. Okay. Now just think about this expression. F of A plus h minus function value, this difference, which is going to be this one. Just think about this difference and divide with the whatever you have this difference, which is A plus h minus A. That means here you have this one. On h, you will get this one. So this difference is actually what? Whatever this one is, you know, all of you know the slope of a line. All of you know slope of a line, right? Slope of a line is what? How we generally find the slope of a line?
That is to run.
Why if you have suppose this is x1 y1 and this is x2 y2. So y2 minus y1 upon x2 minus x1. This is the formula, right? This is the slope of a function. So what is this? The similar thing is we are doing, right? Here is we are with respect to function we are doing. We are actually, this is the y values. So function values is there. So differences we are doing and the inputs difference is giving. So that means here is f of A plus h minus f of A. So this is actually what I'm trying to convince you that it is actually, I'm trying to find the slope of a function. This is happening, slope of a function. Here is the slope of a line is happening. Here is the slope of a function is actually trying to get that. So here is, if this difference is actually, we will try to make it very small, very small. That means very small. This means reach s goes to 0. Yes, we can, here we can do that h.
Sir, again you are not audible.
Okay, so here is as h goes to 0 means, here is h goes to 0 means you are doing the increment, or here this increment is very, very small. And in that case, this increment, so this is actually what is, this is called the now, so this expression limit as x, so limit as h goes to 0, this expression is called, you are checking the differentiability of this function, or this is called the differentiability of the function f at A. Checking if limit is, this limit is exists. Suppose as we are trying to get the limit is on this one, this one. These are the limit you are trying to get that, right? So here is, if you trying to, if this limit is exists, then your function is differentiable at it. If the limit is not exist, then your function is not going to be differentiable at it. This is the mean of differentiability. So for example, I am just explaining, suppose you have a function fx is equal to mod x. So see that what is, I am also tells you the slope of a function. So in different word, suppose you are able to draw the, suppose you are able to find the slope, or you are able to find, you are able to get a slope of, or a tangent line. Here is a slope means generally slope of a function means you are trying to get the slope of that line which touches the graph at here. This one. So what is going to be the slope? So this is actually the slope of this line. This is the mean of, it is actually touching here at it. Okay. This is the mean. So here is at 0, is this function is differentiable mod x? How we can check? So all of you know the mod function. What is the mod function? Mod function is x when x is greater than 0 and minus x when x is less than 0. In that case, this is the mod function. So if you check that, or if you draw the graph of the function, the mod function is actually this one. Graph of the function, or graph of the mod function is this one. There is a sharp corner is happening. So if you try to draw the tangent, what will happen? What will happen in the at 0? What is going to be tangent means here we want to find a line which is touches at 0. Is that line is going to be unique? Anyone?
No, sir, there
Am I
will be
audible?
so many lines.
Yeah, there will going to be so many lines. Even itself, you can see this line, and also this is also the similar thing is happening. Even this line is exactly touching this one, and this line, or also I am just drawing this one. I just drawing here this one. There are many possible lines which exactly touching that point. So in that case, is actually the slope is, this is not saying the slope means, or sorry, tangent line. Tangent line means it is exactly one line which touches the graph. But here the case is what is happening. There is so many lines is happening which touches exactly the graph of the function in the many direction. Here is so many lines we are getting. So in that case, actually we'll say the function is not differentiable. This is another way to say the function is not differentiable means you are unable to find exactly a unique tangent line. There it has so many tangent lines. Okay. This is the mean. So okay. This is the meaning of the tangent line. And also if you check with this case, no, limit as for this function fx is equal to mod x. If you check this limit case, no, this limit will not exist. So easily we can check. So we can check, we want to check the differentiability. Okay, so if you try to find this here, okay, any background noise is going from my side?
No, sir.
No,
Please
sir.
let me know. Okay, fine. So if you try to find here, no, so at 0, this is the function is the function value is going to be 0. So let's check here the differentiability at 0 by the graph we just now checked. Okay, so now let's check via the with the way with the limit case. So limit as h goes to 0. Okay, we want to check at 0. So at 0 it is going to be 0 plus h minus f of 0 upon h. This is the same definition I just wrote here in the limit form, right? This one. This one. Limit h goes to 0. A is here, our a is 0 for this function. We are checking at 0. So now this is going to be what? F of h minus f of 0. Function value at 0 is going to be 0. upon h, this limit as h goes to 0. So now as we have this function, this property as h goes to 0 means here is two cases is happening. Now this is going to be limit as h goes to 0 mod x. So here is going to be mod h upon h. Now as here is h goes to 0, here is suppose you are approaching to 0. Okay, you are approaching to 0. So you have two ways, right? Either this way or this way. You can approach to 0 with the smaller number or negative side and also from positive side. Okay, so here that means here if you are approaching the mod value, once you have the less x is less than 0, this is going to be minus x. So similarly here is if you are approaching to 0, so that means here the generally it is denoting as h goes to 0, h goes to 0. This above minus 0 is means approaching to 0 from negative side. That means here, so this is going to be a minus h upon h. Now this is going to be minus 1, as you can divide minus h upon h is going to be minus 1. And if you approach the limit as from 0 to 0 from positive side, this is the mean of from positive side. You are approaching by this way, this side. This is called the right limit also. This is called the left limit also. You are approaching to 0 by this way. By this way, if you approach, we got minus 1. And by this way you approach, we got here. This is going to be h by h. As positive side, the mod function is going to be exactly we have like this once you have the positive values. That means here this one h by h. So that means your limit is going to be 1 here. So in both cases, what is happening here? So if the limit is actually generally once you have the left element, so this is called left limit, and this is called right limit. Okay, right limit, left limit and right limit. And if the left limit and right limit is not same, then you cannot. Then you will say that limit is not exist. So as the here is happening, that means this function is not differentiable at g. Okay. So let me list out the some functions, the differentiable function. Suppose you have function fx is equal to e power x. So the derivative of the function is actually exactly the e power x. If you do the derivative with respect to x, this function, this is going to be e power x. If you have sin x, then derivative of the function is going to be cos x. Derivative means what? Derivative means you are deriving or you are derivating this function with respect to x, means you are actually trying to get the limit h goes to 0 for this function f of x plus h minus f of x upon h. With respect to general case, you are getting this limit. So that's why this is going to be cos x. Cos x is gives the minus sin x. Log or logarithmic function x goes to be minus 1 by x, and x to the power n give the n time x to the power n minus 1. The derivative is. This is the most important. These are what I'm just writing. These are the important function. And some other functions you can check with on search on the Google derivative of the different function. You will get that what is the derivative of the function. This is called derivative or differentiability of the function. Now once you know the derivative, so there is now terms came the critical point. Suppose you have a function, okay, so what is the critical point means? Suppose I am just drawing this graph, okay, graph, this is the graph of function. So at this point, all of you gone through the polynomial, polynomial they have some turning point. So suppose this graph is of a polynomial. So see that these are the turning points we have, right? These are the turning points we have. So what is actually happening here? And the function is actually started increasing, and then from here it is decreasing. This is started increasing, then again decreasing. Here is the similar thing is happening. So what is this one is actually called the local maximum. It's called local maximum. As here here you can see this is started decreasing and suddenly started increasing. So this is called a local minima. So this is the local maxima, this is the local maxima, this is the local minima, this is the local minima. So there is a local maxima and local minima. So these points is actually called the critical point. So at this point, some function have some local maxima or local minima. So these points are actually called the critical point. So how we'll get the critical points? I will try to find the critical point. Is that clear? I just know whatever I'm talking here. Is that clear?
Yes, sir.
No? Yes? Anyone?
Yes, sir.
Yes, sir.
Okay. And my voice is clear, right?
Yes, sir.
Yes, sir.
Okay. So these points are actually these points is actually called the critical point. So see that what is happening here and the different word I am showing you. If you draw the tangent, tangent line at here, can we, what is going to be the slope of this tangent? While looking itself, you can tell what is the slope is happening here.
0.
0.
0, right? This is the slope is actually 0 is happening. So that means if you have a function, okay, suppose you have a function and if suppose we want to find the critical point. So how we can get, just derivate this function, just find the derivative. So derivative means here either I could write like this or I'm just writing f prime also. So just derivate this function and equate to 0. That means this critical point have the slope 0. That means if you equate that function equate to 0, then we can get the critical points, right? Or another way is if the function is not differentiable at that point for this mod function. Here as is, this one is also a critical point, as here we know this at here the function is not differentiable. So there are many ways. There are two things. A function is not differentiable at a point, or the derivative of the function is 0. Those point is actually called the critical points. Okay, it's like here, this one. Okay, so suppose I am just writing a function fx is equal to x cube minus 1, or let me write here x cube plus 2x minus 1. And I want to find the critical point of this function. So what I can do, just derivate this function fx. So this is going to be 3x square. As here, just x to the power n, the derivative of this function is n times x to the power minus 1. Using this one, I'm just saying it will multiply 3 and subtract with the minus 1. So this will become 3x square. And this is again the 2. Okay, this is we have. So now you have this derivative. I derivated this function, we got this one. Now equate to 0. Equate to 0 and try to find the value of x. So if you try to find 3x square is equal to minus 2, here is 3x square is equal to minus 2. So there is no real number which give this equation as equal to 0. That means if you try to graph this function, there is no critical point. That means there is no local maxima, local minima is going to happen. Suppose I am trying to do like this. I have different function. I just differently or choose the function which don't have the critical point. I'm just choosing here x cube minus 3x, okay, plus 1. Suppose you have a function this one. Just derivate this function. This is going to be 3x square minus 3. Now equate to 0 here. So this is going to be x square minus 1 is equal to 0. That means here, what is going to be the value of x here? Value of x is going to be plus minus or plus minus 1, right? So here we have two critical points. So this, if you draw the graph of this function, at least at 2 points, at minus 1 and at 1, it has some local maxima and minima. I don't know exact graph, but I can, without drawing the graph, I can tell you at 1 and at minus 1, it has some local maxima or minimum. But how we can sure that at 1 it is have the local maxima and at minus 1 it have the local minima, or the vice versa? We don't know how to get that. So there is another test. So if you do that, here is, once we derivated this one, no? So again derivate this function, means 2 times. Just again this derivate this function. I am just writing in the 2 primes here, f double prime. to derivate this function, again, this is going to be 6x, right? Now, if you substitute it here, derivated this function, and we have calculated the critical point. Now, if you substitute the value here, 1 and minus 1 in that, if you substitute 1 here, this give what? 6. And if you substitute minus 1, this give minus 6. And what is the test? So this is called, I am actually called the second derivative test. This is called second derivative test. So what I am trying to do, I am actually checking at 1, what is that have local maxima or minima, at minus 1, if that the function have local maxima or minima. So there is a condition that if the f double prime x is greater than 0, okay, at suppose at critical point A, the double prime A is greater than 0, then it have the local minima. Greater than 0 means minima. If double prime less than 0, then it have local maxima. So as here, this is greater than 0. So that means here at 1, it have local maxima, like as the similar to the local maxima. At minus 1, sorry, it is greater than 0. So local minima, no? Greater than 0 means local minima. So it is differently, it is like this. Minus 1 like this, it will have the local minimum. Or here is not, here is differently. I don't know the graph, but at 1, it is going to be local minima. At minus 1, it is less than 0, then it have local maximum. Okay. This is the second derivative case, is this. Okay. So all of you are getting why I just quickly revising the thing is that clear now?
So one doubt, sir. Why is it great when x is equal to 1? We get double differentiation, we get 6. It is a positive number. And why are we saying it is a local minima?
So this is a test. This is a derivative test. If it is greater than 0, okay, in that case, at the critical point, it have local minimum. And if it is less than 0, then it have the local maximum. And why it is such? This is just a rule. If you, for this time, at least for this revision session, you can think this is just a rule. You can believe on me that this is the correct one. Otherwise, there is an analytical way to think that why it is such. Okay. And we can discuss that, but because of time constraint, we are not going to discuss in the deeper why it is such, because that then there is a concept, no, there is then you need to study about the you have to study BSc in mathematics, then you will know more better or more go deeper. That's the BSc thing in mathematics wing. You are more analytically, you will do that.
That's fine, sir. Thank you.
So this is a test. So this is called second derivative test. If it is greater than 0, then it have local minima. And if it is less than 0, then it has local maximum. So this is the local maxima, minima, and critical point all about. Now next is the integration. Integration. So as we know, no, just now I just said e power x. If we derivate this function, it will give e power x. If you have sine function, derivate this function, it will give cos x. And if you have cos x, then if you derivate this function, it will give minus sin x. So integration is just a reverse part, just the reverse thing. What is that? If you integrate this function, you will get this one. If you integrate this one, you will get this one. Just the reverse thing. Differentiation is, or integration is just the reverse part of the integration. Differentiation means you are trying to get the, or more deeper, you are trying to analyze that, and integration is you are trying to sum of, integrate. Differentiation means you are trying to divide the function, but integration means you are summing the function. So as here, that's why it is differentiation is just or integration is just the reverse thing. So integration sign is like this. Okay. Okay. So if you integrate this function e power x, the same, now just reverse is e power x means just reverse, it is going to be exactly e power x. If you integrate cos x, what is going to be the integration of this one? Just reverse function. This is going to be Sin x. What is the integration of the sin x? Can you tell me now? So here is dx. This is the sign of integration. What is the integration here? So can you tell me what is the integration of sin x?
Minus cos.
Minus cos x. Because here the integration of differentiation of cos x is minus sin x. So if you think about minus cos x, differentiability is going to be sin x, right? Because cos x, if you differentiate cos x, you will get minus sin x. So can we think about the minus cos x? It will give sin x. So that means just the reverse part is going to be minus cos x. Similarly, integration of 1 by x is going to be ln x, log with base e x. Integration of constant function or integration of constant or integration of 0 means, if you have suppose I'm just writing like this. Suppose fx is 2x square, or let's say I'm just writing 2x plus e power x plus sin x plus x square. Okay, what is going to be integration of this function? Integration of this function is just integrate separately. The integration of 2 power x plus integration of e power x plus integration of. So here is dx will be replaced at every place. Here means dx means what? You are integrating with respect to that variable. That's it. This is just a notation. So integration sign is finally you can say like this. Now here is dx and here is dx and here is sin dx and here is integration x square dx. So separately you can do. Here is you can, with respect to sign, you can separate your integration. Now here is going to be what I don't know what is going to be the integration of this one. Can anybody tell what is going to be integration of this one? 2 power x. I don't remember the formula. What is that formula? If you are integrating that function. This is something 2 power x
plus
no,
1
no,
divided
2
by x
power
plus
x
1.
divided by log with base e2, right? This is going to be, I think so. A power x, that differentiation is a power x, differentiation of a power x is a power x into log something is there, log with base c or a something is there. So integration is just a reverse of that. I'm not remember, I don't have remembered this formula exactly, but I think it is the similar. You just need to divide with that. Okay, just see on, we can search on exactly on Google what is the integration. Here you can see. I'm just searching the integration. You can search on, you can get all very quickly. These are some formulas we have. This is a very big like sine and power x, so we don't want this one. Easy formulas because some easy questions will come, not a very difficult. So like this is integration of x to the power n is x to the power n is going to be x to the power n plus 1 upon n plus 1. So this is the similar. So, and I don't know what is the exactly a power x is that. This is, yeah, this is one, this is a differentiation and the reversal part of it. That is not a big. So here is, we can say that integration of a power x is going to be a power x divided by log. So whatever I just wrote, that is a correct one. So you can list out this. This is the simple one. So you can remember this all. At least not all. At least for till here you can remember, not below of it. So similarly, like if A is going to be this one, 1 by x is this one, if x is this one. So each time I just forget to add the plus c is there. That means here is going to be plus c is there. What is plus c means? If you differentiate the function, a constant function, you'll get the 0. So if you reverse that, means you need to add the constant thing. So this is a constant. So if you remember that formula, here is that's why if you see that this formula, each time c is added, that means the constant thing. Okay. So this we have. So this is the integration. So this is the indefinite integration, and the definite integration is there also. It is just need to substitute the values. So what is the definite integration is? Just need to, if you suppose here is -1 to 1, if you want to find the integration of 2 power x, so this here is dx. So that means just integrate this function. This is going to be 2 power x upon log 2, and then substitute the limit -1 to 1. That means here I am just in this fashion, I am just writing. This tells you this, or differently also. Here is this fashion means, this means that you are trying to find the limit as x goes to 1, 2 power x upon log 2 minus limit as x goes to 1, 2 power x upon -1, 2 power x upon log. Means here is the limit case is written here, means here just need to substitute here. If you substitute here 1, and this is going to be 2 power 1 upon log 2, and now minus, and then this limit is there. This is 2 power -1 upon log. This is the meaning. So just need to integrate and just substitute the limit thing is integration. Okay. So this is these are about the this is all about the calculus portion, sequence of function, sequence of limit of sequence, limit of function, maxima, minima, continuity, differentiability, critical points, integration. Okay, these are the topics is are in the calculus. Okay. Now let's move on to the graph theory portion. So I think I have almost discussed this in the integration, critical point, maxima, minima, integration, differentiability, continuity, and sequences. I'm just quickly revising, because if you start teaching, then it will within 2 hours it is not going to be finished. So I'm just telling you what are the topics we are going to ask in the question in the qualifier exam. And I'm just revising that these are the topics and these are the definitions we have. And just whatever I am discussing here, if you know this much knowledge is enough to solve that whatever is going to come in the exam. Left limit, right limit, continuity, differentiability, mod functions, floor functions, integrations, whatever I'm just discussing, this much if you know, then you can even solve half of the QPs, I will suggest. I can say. So not going to be more tougher. Am I audible?
Yes, sir.
Oh.
Sir,
Now let's.
Sir, could you repeat the last sentence which you said, sir?
Last sentence is the means here is the QP or question paper is not going to be more tougher. If you not going to be tough, not even it means moderate it will be. If you whatever we discuss now, this formulas, then if you learn this 4 types of formulas, some added one here, some a power x and integration of ln x, this one, and also sequence, finding the limit of sequence, finding the limit of functions, continuity, differentiability of mod functions, and also graph wise like this. Graph wise we also seen the differentiability. So if you know whatever we just now discussed, if you revise or only whatever I am discussing the topic, if you revise that till here whatever I am discussing, that's enough to solve the QP. QP is not, question paper is not going to be deeper or tough. So now let's move on the graph theory portion. Okay. In graph theory, what is the graph? So why this theory is generated? The simple reason is, okay, the simply is, suppose you are traveling to one city to another city, to suppose you are traveling by bike or car or anything, you are traveling in the cities here by this route. So this is, see what I am trying to say. This is one city one, this is city two, this is city three. So this is the route, this is the route map is given. Okay. So see that this is a structured form, no? This is this structure. I'm just trying to give. So this is the kind of structure you can tell about. This is the, you can relate with the graph. This is the graph. That's why from the graph theory. Even you can, if you see the route of the our railway path of even one city itself, or two city, or even one state, you can tell that, or your whole India, you can. That if you have a road map of that, okay, this will represent a kind of a graph thing. So why it is generated is the graph theory come as, suppose you want to find, or you want to go to reach city one to city two, okay, or even the the flight thing is there, the airlines routes. If you see the airlines routes, you can able to reach from one city to another city. There may be possibility that there is no direct flight you can get. You can connecting flight it have, okay, some one city you have to reach some another city, and then from there to have to some reach to another city. Okay, so the routes, if you see the flight routes, then that is also kind of represent a graph thing. The graph theory is actually generated here. So there are many ways. There are many things to study on the graph, like try to minimize the cost of traveling, try to there is one the minimum cost spanning tree is actually for that purpose, is trying to minimize, or there is any shortest path to reach out the one city to another city with the minimum cost. There are many problems on the graph theory which could be solved. There are many real life problems which could be solved using the graph theory. That's why the graph thing came. And in this, whatever you are going to discuss, it contains some algorithms, means how to find the minimum cost of a way, a minimum cost of the shortest path, which route I will go so that it will cost me minimum. Okay, so like this, we'll see it here. So the first thing is about the, so this what I just drawn here. So let me take an example here. Yeah. I just need to take at least one graph. So let me take a graph. So this is, see that this is the graph we have, okay. And also I let me explain you what is the whole thing is here happening in the graph. So see that this is a directed graph, no, there is a direction is given. This is the direction, this is the direction, this is the direction. So this is called directed graph. Okay, this graph is directed. Okay, this is directed graph. And yeah, please, if anyone have the link of let me, and I can share the Vishal's drive link. Then this one is this. Okay, so this is the directed graph. If the suppose the direction is not given, no? These are the direction. If suppose the direction is not given, so that is called undirected graph. If direction is not given, that is undirected graph. If the direction is given, then that is a directed graph. and undirected. This is for undirected. So this is for directed graph we have. And let me explain. So here is, this is the 6 written here. No? This is 10 we have. This is 1 we have. This is -10. So this is the weight of this edge. So that means here is, suppose this graph is, suppose this is the city 0, this is city 1, and this is the route, and this is the cost of traveling. And this is, here is a -2 is given. No, just neglect that. Even suppose minus, you can neglect that. I'm just writing here 2, not minus is there. Here is 8. Where is the minus thing? No, I just removing that. We'll explain you why it is minus is there. So suppose this is the cost. So this is one city, and this is the traveling cost to city 7 to city 6, traveling cost. So this is the traveling cost by the route. This is the traveling cost. Okay. So this weight, this edge is actually, you can say the route is, this route is representing the route. So this is called edge. This is called edge. Okay. And this is called vertex. The node point. So see that two edges is actually meeting at here. So this is called vertex, and this line is actually called edges. This is an edge, and whatever the number is written here, no, this 10, this is 4, this is 4 here. So that is the weight of the edge. Means here is this is the route of reaching to the city 6 to 3, and this is the cost. 4 rupees, 5 rupees, 10 rupees. So this is the cost. Okay, now let me erase here. So I hope you got that. This one, that what is this number is written there. So this is a weight written there. Okay, and this is called vertex. This is called edges. Okay, and this is the weight is written there. Now there is this thing, adjacency matrix. So this is a representation. This is a graphically representing. No, this is the graphical representation. We can represent this function or this graph a different way in the form of matrix, or let me write that. What is that form? So I am just listing out in the list form. You can write that.
Sorry
You
to
can
interrupt
list.
you, sir.
Yes.
Can you please explain words that arrow represent?
So arrow is actually says, I think you did not listen. This is actually saying the direction. So see that from city 0, you cannot reach city 0. You cannot come to the city 0, but from city 0, you can only go out. Okay. Means here, this is called outgoing edges also. Here is this is the directed. So this graph is actually directed graph. This is not undirected graph. Undirected graph means direction will be not given in the edges. Okay.
Okay.
Is that clear now?
It
Okay,
means
now
we
I am
cannot travel from 7 to 0, right? We can only
yes, that
travel
means
from
here
0
7
to
to 0.
7.
We cannot travel to 7 to 0. Only we can travel by this. So here is the traveling. No, so there are many real life example which have such kind of. If you try to graph that real life problem in the graph format, you will get some similar thing. So there is possibility that by this way, or there is a possibility that if you once you try to graph that problem, no, by this way it actually represents. So this is the one thing we have. Okay? This is one. I'm just not saying if you are able to reach city from 0 to 7, then by reverse you can go. But it is actually the purposely this problem is in the different scenario it is given. I'm just explaining in the case for the city reaching to the city. Okay, so this is the representation is here is 0, 1. So whatever the edges we have, no, sorry, vertices we have, no, I'm just representing that here is this side I'm writing 0, 1, 2, 3, 4, 5, 6, 7, and 8. And what is again is happening? I will write the with the vertical lines also. Here it is 0, 1, 2, 3, 4, 5, 6, 7. So not there is no 8, no. So there we don't want 8. Only 7 is the 7. Okay. I'm trying to, here is no, I just, let me take another example, because this is the weight graph. This is also called the weight directed graph. I want a, which don't have the weight. So adjacency matrix will be related to that. So
We can ignore the weight and we can just use the vertices and edges, right?
example. So maybe other people will not get, that's why I'm just taking the different graph. Okay, so just a minute. So what is happening if you ignore the weight? No? Suppose I'm just saying, just ignore the weights. Okay, even let me erase it here. Just ignore the for the timing, just ignore this one, the numbers. Okay, only the edges is given, no? Only the edges is given. Just ignore this one. Okay. Now see that this tells you 0 to 7 it have edge in this direction. So this tells you 0 to 7. So where there is an edge, write 1. Okay. If there is no edge, write 0. Okay. And 0 to 1, 0 to 1, it this graph have an edge. Here is 1. Okay, 0 to 1, and rest all 0 to 2 or 0 to 2 or 0 to 5, 7, 4, 3, whatever the number is, there is no edge, no? So you can write there 0. In place of that, you just write there 0.
So 0 to 4.
And
we have
also
an
4 we have,
zero to four.
sorry, 0 to 4 we have. So here is 0 to 4, this write like here. And also 0, with respect to that means 0 to 0, you can always write 0 there. Okay, or 1 to 1, there will be 0. So for directed graph, I am writing here 0 and 1. Okay. If it is there is an edge, write here there 1. If it is there is no edge, then write 0 there. Like 1 to, like now 1 to 0. 1 to 0. Now see that this tells you, I'm just write out even 1 to 0. Now here 1 to 0 means this edge is asking, but there is no, there is, this side is given. So that means this edge is actually this side, not this one. So that means here you need to write for 0, not 1. But this is a directed. Suppose the case is here. I'm just saying here is both side, or both side not here. Suppose the case is happening. Suppose there is no direction is given. For the time being, you can also forget about the direction. Then it will be more better. Just forget about the direction. There is no direction. This is an single edge. This is suppose this is an undirected graph. This is an undirected graph. So this is an edge. This is a single edge. So that means here is 0 to 1, we have an edge. So here is 1 to 0, there will be an edge. 0 to 7, we have an edge. So sorry, we started from 1, no? So 1 to 2. So 1 to 2, we have an edge. So 1 and 2, there will be 1. And from 1 to any other is, there is no an edge. So in place of that, we just write 0. Similarly for 2. So from 2 to 7, we have a, so forget about the direction here. 2 to 7, we have. So 2 to 7. Here is 1. And 2 to 5, we have. 2 to 5, we have. And then 2 to 5, 2 to 7, and 2 to 3, we have. 2 to 3, we have. And rest all will be, you need to fill 0. So like this, if you fill the entry, this is called adjacency matrix. Adjacency matrix. This is called adjacency matrix. So see that this graph is exactly representing, we can represent this graph by this way also. Or suppose if you have, okay, suppose if it is given an adjacency matrix, you can draw this graph. Suppose I'm just taking the adjacency matrix by this way. There. So this matrix will be of matrix. Here is means here what the number of rows will be given, So it is 0, 1, 3, 0, 1. So here I am writing 1, 0, and sorry, voice is not clear. Okay.
Yes, sir.
Is it better now?
Yes, sir.
Is it better?
Yes, sir. Yes.
Now let me write it here. So 0 to 0 will be 0. Like I'm writing here 0 to 1, 2, and 3 is at 0. It is 0. Okay. And please just stop me if my voice is not clear. Okay. And from 1 to 0 is we have 1 to 0. So 1 to 0 is 1. And here is going to be 1 to 2. Suppose 1 to 1 will be 0, and 1 to 2 is 0, 0. And is for 2, 2 to is this going to and 2 to 0 to 2 1 we have 0, 2 to 3, let's say 2 to 2 will be 0, 2 to 3 will be 1, and now 3 to 0 will be 0, 3 to 1, 3 to
Stuck.
3 to 0. Am I audible right now properly?
Yes, sir.
Okay. So suppose this is the adjacency matrix. Okay, this is the 0 to 2 we have, and 2. I'm just filling out here number. 2 to 2 we have. So this is 1 and 0. Okay. Now, I suppose I want to form the graph of here. So graph will be. So now see that the graph. We can write here 0. So here is. I'm just writing 0, 1, 2, and 3 is here. Now 0 to 1 we have. So 0 to 1 we have edge, and 0 to 2 we have edge. This is the 0 to 1. So see that this is 1 here. So that means 0 to 1 means here is an edge. Now take 2 and rest all are 0. So that means 0 to 3 there will be no edge. Okay. Now 1 to 1. Sorry, 1 to 0. So 1 to 0 already we have drawn. And 1 to rest all are 0. So there is no edge connecting to 1. Now 2 to 0. So 2 to 0 already we have as previous one. 2 to 3 we have. That means this is the graph. Now 3 to and rest all are 0 means 0. Here is 3 to 0, 0. 3 to 0, yeah. 3 to 1 is there is no 3 to 1 already 0. 3 to 2 we have. So we have drawn this one, and 3 to 3 will be 0. So see that this adjacency matrix is actually we have drawn a graph here. This is an undirected graph. Even for a directed also we can draw. If it is direction is given, means if it is the reverse side is not given, you can give you can give 0 there, and in that direction it is given, you can give 1 there. So even we can draw the graph or undirected graph also. Okay. Now once you have the graph, no. So this is called adjacency matrix, and we have draw the graph. So there are some concepts. Now let's talk about the concept. So there is a graph coloring thing. So Suppose I'm just drawing this graph. Okay, let me take another example. So this is the representation. I need to take this one easy. If you took this one, then easily we can do. So suppose okay, I'm just taking this graph. Okay. Okay, I'm just taking this graph. Okay, now, so there is one concept, graph coloring, means we want try to graph. So trying to color the graph means color means here we trying to graph the vertex, this vertex. We want we want to find the number of colors, minimum number of colors which we can give, so that like here is means here is coloring means if we suppose we colored this one with the red one. Suppose I just color with the red one. So connecting edge, we cannot color this one with the red. Okay. But I can color this one with the red. So connecting with the, if it is the vertex is connected with the edge, you cannot color with this one. So this one we can color. Okay. This one we can color. So if we color this one, we cannot color red by this one or by this one. So we cannot color this vertex and this vertex, even this vertex, but we can color this vertex. Once we color this vertex, we cannot color this vertex with the same color. So we can color this one. Now we can, if you suppose I just take another color. So now we start feeling that. So I just colored with the pink here, this one. Okay, now we can color this one, right? This is the one. So now this we can color, this is not connected, but we cannot color pink with this color. Okay, but we can pink this vertex, this we can color by the pink with this vertex, to this vertex. Now we need to take another color, so we can take green here. This one. So see that there are these many vertices we have. Okay, but only how many colors is needed to color this one is 3. So this is called the minimum, or this is called the graph coloring problem. So there could be possibility that we can color, or there could be, the question will be like that, find the minimum number of color to color the graph. So see that how many colors we required. We needed 3 only, 3 minimum number of color we want. So 3 colors is needed to color this graph. When we can get the more color, no, we can fill with the different color also. But we want the minimum number of color to color the graph. This is called the minimum graph coloring problem. So you can now solve such problem. Okay, I just explaining you what is the minimum number of colors is required. So this is one type of problem. There is another type of problem. So let me explain it here. And so suppose the same graph I have. So suppose this is a building, no, and this is the corridor. Okay, this is the corridor we have. This is the building, and these are this edges is actually tells you the corridor. Okay. And we want to fit cameras here. Okay, we want to fit the cameras to watch the corridors. Okay, so where we can fit the camera? So I can fit here camera, I can fit here camera, I can fit here camera, either we can. But we want to find the minimum number of cameras so that we can fit, and it covers the all possible corridors. What is that minimum number? That is called the vertex cover. We are trying to cover the edges. So here is what is that? If we cover here, here we put camera here. Okay, if you suppose we can put here camera. So this corridor is done, this corridor is done. Okay, now if you put here camera, okay, So this corridor, this corridor, this corridor, this corridor is could be watched from there. Okay. And now if you put here camera, okay, then this corridor is done, this corridor is done. Now if you put here camera, this corridor is done, this corridor is done. So see how to watch the whole building, only 4 camera is enough to fit the camera. No, minimum. Either see in starting I can fit the camera here, here, here. There are so many possible ways to fit the camera, but we want the minimum number of cameras to fit that. This is called the minimum vertex cover. We are trying to cover the, okay, we are trying to find the vertices which cover the whole graph, whole the edges. Okay, this is called the minimum vertex cover. What is going to be that? This is another type of problem. Okay. Now this is the graph coloring thing is done, and this is the vertex cover. Now let's see the another is adjacency we done. Now let's talk about, sorry,
So minimum
somebody's
3
on.
cameras.
So minimum 3, is there any other way to cover this one?
Yes,
Yeah, you can tell me.
At B7 we don't need a camera, sir. Actually.
At B7, okay, B7, we don't need a
Bottom
camera.
part.
Here is. Then how we can this one
From
we can see.
B5. From B5
From
we can see
B5.
B4.
No, how I can see this one, this edge.
Okay.
To watch
Sir,
this sorry.
From B8, we can watch B9 and B10. From B5, we can watch B4 and B7. From B1, we can watch B2 and B3, sir.
So here is not only the edge vertices, no, we want to cover the edges. We want to see here the edges, not the vertices.
B1 we can cover, from B1, we can cover B2 and B3 and B5. From B5, we can cover B6, B4 and B7. From
Okay.
B8,
Yes.
we can cover B9 and B10. So there are only 3 cameras needed now.
No. Here is the cover means here you are covering the vertices. No, I am actually covering the edges. I want to fit the camera so that I can see the corridors, no? This corridors, not only the vertices. I'm not going to see from this one to. Sorry?
I have only question. From B7, what is the need of B7, sir? B7
So if you suppose if you remove B7, okay?
Okay.
Then what will I can see this corridor, but how I can see this corridor? How I can see? I have to fit somewhere here or here. Without that, I cannot see this corridor, right? In between, this is a building. How I can see this one? This edge.
Okay, if it is a building, okay. Fine.
This is called, so that's why we needed at least 4 cameras to cover. Yes.
There is a vertex,
Yes.
we need a camera. If from B3 and B2, there is no vertex along B3 and B2, so there is no need of camera. Okay, sir. Fine.
Am I audible?
From B1, from B1 to B3 and B2, there is no line between B3 and B2, so there is no need of camera. You are saying that, sir? Hello?
Sorry.
You are not audible.
Hello? Sir, you are not audible, sir. Hello?
Yes, I just disconnected. Okay, yes, sorry for that. So can you tell me what you are saying? Could you repeat, please?
There is a line between, there is no line between B2 and B3. So if
B2
we
and
choose a
B3.
building,
Yes.
okay, there is no vertex between B2 and B3. So there is no need of extra camera between them.
Yeah,
So
we don't want.
We don't want. So if there is a building between B4 and B7, so there we need a camera. Is that right, sir?
Yes. If it is here is the one room, here is another. So this is one corridor. No, how I can watch the corridor? The problem is how I can say I want to choose such vertices so that I can cover the edges. Yes, that's the meaning here. How I can choose the vertices so that I can all edges and minimum number of vertices I want. Okay.
Clarified, sir. Thank you.
Minimum number of vertices I want. So that I can cover the all
Sir,
edges.
your voice is
I
disconnected.
can watch the all edges from there. That is the minimum vertex cover. I'm trying to cover the edges minimum number of vertices using the minimum number of vertices. That is the minimum vertex cover. Okay, it will be stabilized. Just a minute. Is it better now? Is it better
Yes, sir. Yes, sir.
now?
Yes, sir,
No,
it's
sir.
better.
There is a glitch, sir. There is a glitch between your voice. Hello, sir. There is a glitch.
Am I audible? Is it better now?
Yeah, sir. Now you are audible, sir.
Am I
Yes,
audible
sir.
right now properly? Okay. So here
Yes,
is
sir.
minimum vertex cover means you are okay. So here is minimum vertex cover is we are trying to find the minimum number of vertices which cover the all edges. Okay. That is the minimum vertex cover. So here is that's the I purposely said that here I try to explain that concept with the cameras. Now let's move on to the another that is called BFS DFS. Okay. Here is BFS. What is the breadth first? So we are going to discuss only with the breadth first search. Okay. The DFS we are not going to search means that is not will come in the exam. Okay. So breadth first search is what is the breadth first search is? This is an algorithm to analyze the graph. Okay, and it will give a tree that is called BFS tree. Okay. This is the BFS is actually an algorithm to analyze the graph, and it is actually give a tree which is called a BFS tree. Okay. So what is the BFS tree is that actually what is the algorithm? We are trying to start our algorithm from suppose this vertex. Okay. What is that? Suppose I started our algorithm from this vertex. Okay. So from this vertex, I can visit from this vertex, I can see this vertex, right? Only this vertex. I cannot see this vertex. So what it means that I from this vertex from B1, I can reaches to B2. Sorry, from B0, I reaches to B1. And once I reaches, I can start exploring again B1 means I can from B1 I can see vertex B3, I can see vertex 5. So let's count that. Okay, let's count that. So let's list out that from B1. Okay, from B1 I can see B3. What is that here? B3 and B5. Okay. So from B1 I can see B3 and B5. Okay. So now go to B3 here again. So from B3 we can only see B1, no other. So just stop that. Now let's go to B5. Okay, now let's reach to B5, and from B5 I can see B6, I can see B4, I can see B7. Okay, from B4, sorry, from B5, this is B5 here. From B5 I can see this one, and this one. Now let's start again exploring. Okay, let's reach to B6. I can only see B5. Okay, so stop it here. From B4 I can only see B7 and B5. It's already explored by this one, so stop this one and let's reach to the B7. From B7 I can see B5 and B4. From B7 I can see B4 and B5. Okay, so now and also B0. Here is B0. What is then here? This number here is B2. No, I just wrote B0. This is B2. Okay. Now I can see B0. So I can see here B0. So I can extract new vertex which is B0. Okay, already other things we have done. So let's reach to B0. From B0 I can see B8, which is B8. I already B7 is there. That's fine. We have already explored it here, but I can visit B8. Okay, so now let's explore B8. From B8, I can see B9 and I can see B0. B0 is already done. So B9 we can see. Now let's reach to B9 and from B9 I can see only B8. So it is already done. So let's stop the exploring thing. So this is called actually what I am doing and actually I am trying to explore breadth first search. This is called breadth first search, BFS. So what I did here, I actually searched the our graph, whatever we have, the graph we did. This is the search we did. So see that what is the missing thing we have from the graph previous one. This edge is actually we removed. There is no edge. So if you see that this is a tree. This is a tree. This is called a tree. Tree is actually the definition of trees. Tree is a graph. Okay. Tree is a graph which does not contain any cycle. Tree is a graph which does not contain any cycle. So suppose for this graph you see that this contains a cycle. No, this is a cycle is happening. So this is not a tree, but if you see this one, this is a tree. There is no cycle is happening. So this is called BFS tree. And whatever I used the algorithm while speaking, I just explained the algorithm. No? So this is called breadth first search algorithm. And this is called, after using that algorithm, we reaches to this BFS tree. Okay. So try to see some from YouTube, or we have also try to see some other places, or even in the it is available on our this BS online day. You can search there. I'm just explaining here what are the topics is there, what is inside that. Okay, so that's why I explained the BFS tree and adjacency matrix, vertex cover.
So there is a glitch, sir. Sir, you are not audible.
So suppose again I'm taking the graph is there. Yeah, I'm just again taking this graph. Okay, in this graph, I want to find the longest path here. Sorry, yes. What's your doubt?
Sir, is there any rule to start from which vertex we have to start?
No. It will be given. It will be given in the question. I started from B2, no, but it will be given in the problem that from which place you will start. Okay. Now suppose this is the same graph we have, and I want to find the longest path here. Means longest. Suppose this is the longest path, by which way I will go, so that which give the maximum number of edges we have to cover. Maximum number of edges. So what is going to be the longest path? So the longest path is why looking at the graph you can tell. Okay. So what is going to be the longest path? Suppose it started from B2 by this way and this way. Okay. And then this is, you can go, and then this, and then this, then this, and this is. So what is the order? B2, B1, B5, B4, B7, B0, B8, and B9. This is the order of vertices we have. And what is the finally length? This is 1, this is 2, this is 3, 4, 5, 6, 7. The length is the. So if you search any other, so this is the one path, no, this is one path. So this is one path we have. We can find the path with a path in this graph. Okay? If you go with the different way, no, if you go B2, then B5, then here, then direct 5, 6, only 6 edges is including. But if you see that there are 7 edges, so this is the process actually, or this is the way to find the longest. So this is one of the longest path in this graph. So there you can see some problem related to that. Graph is given there, and you have to find, or you have to find the vertex in the order in which you are getting the longest path. This is a simple one problem. It is not going to be tough. Okay. So let me tell you now the another, which is called the minimum cost spanning tree. Okay. And the Prism algorithm and Kruskal algorithm we will see. Okay, that is a minimum cost spanning tree. So I just now explain you about the tree. What is that? Tree is a graph which does not contain any cycle. Okay. Now the same graph I am taking, or let me take this weighted graph. No, let me take a weighted graph from the.
No, sir, I have a doubt.
What's your doubt? What is your doubt?
Sir, in longest path, it is not important to cover all the vertex.
Yeah, it is not necessary. Just I want to find a path which is going to be the longer. Means we will try to find the such path which contain maximum number of edges, which cover the maximum number of edges. I try to find such path. Not all. It is not necessary to cover the all edges or anything.
Also, a vertex which is visited should not be visited again. That is the rule.
That is one condition. It will continue. It will be in the continue path. Okay, so let me take this problem, and I want to find. Okay, I want to find the spanning tree. Spanning trees means what? Spanning tree means tree we know, tree we got. Spanning tree means I want to try to find such tree. Means spanning tree is a tree which contain all vertices. Here means if you try to graph, suppose this is the graph we have. Okay, so see that this is the tree VFS tree. No? So see that this is the tree. Even this is a spanning tree because the is contain all vertices. See that all vertices is covered. This one is covered the all vertices. Okay. Is covered the all vertices. So this is a spanning tree. So there could be possibility if I remove this one. This is a tree. This is a tree, but it is not a spanning tree of this one. Okay. You need to. We needed all vertices. Okay. So this is the mean of a spanning tree. So can we get a spanning tree of this graph which have the minimum weight? Here we write, here is the weight, right? This is the weight written. Can we get a minimum? Can we get a graph when we get a spanning tree which have the minimum weight? There are more possibility that I can see. There is a possibility that we can get another graph which have a spanning tree. So there is for a graph, there are more different spanning tree can be possible. Even for this one also we will see. But we want a spanning tree which have the minimum weight. Like here, this one we want. For this one, how we can get this one then? So there is a two algorithm which is called Prim's algorithm and Kruskal algorithm. So Prim's algorithm now I am talking here. So what is that? So how to get the spanning tree means choose the minimum weight graph. So see that this is the one, no? Either you can choose this one or this one. Okay. Choose the minimum weight graph. So I just choose just this one. Okay. I choose just with the minimum weight. Now from here, try to expand your graph. So try to expand means if you expand by this way, okay, with these two vertices, if you're expanding, so this is the max, this is the 4, right? This is 4, and try to expand by this way, this have the 2. So go with the minimum one. So like this. So this is 1 and this is 2. Go with the minimum one. Now from these 3, try to expand your graph. So either this way, this way. So see that. So which have now using this one, I can, if you go with this way, this give the minimum graph, minimum weight. If you go by this way, this then it does not have minimum, right? 4 is there. So forget about that. Try to do this is 2. Now if you from D, if you try to expand here, so this give the minimum 2 is there. Now from C, in compare of expanding this one, if you go by this way, then it have minimum. See that this is 3 here. Now if you from here, if you try to expand which way if you go or the same, whatever we have the till here, the vertices, no, try to expand which have the minimum. So by this way, by this vertex or by this vertex or this vertex, from whatever the vertex we have type 1, this have minimum. This is 1. And if you try to And if you try to expand by the E, it have the 4. Okay, so we can stop, we will later see. Okay, so if we go by this way, we have 1. And now, okay, this G is stuck. So we see that in previously, if we draw, then it will give 4, but we don't want, we are actually covered the vertex G now. Now, if you from this graph, try to expand. So if you go by this way, it will give 5. By this way, if you go, then this give 4. So let's move by this way. So this give 4. And now remaining through, we are done this vertex. And now C have, if we go by C here, then it will give 5. But if you go by this way, then it will give 3. So this is the spanning tree. What are you looking at? How we search? We chooses the minimum one and we are trying to grow. We are trying to go with the minimum weight. Okay, minimum number of whatever the weight is given. So this is actually the Prim's algorithm. This is Prim's algorithm. Both algorithm give the minimum cost spanning tree. Okay, so whatever the spanning tree will get, it give the minimum cost, whatever the minimum cost possible. So here now count the weight. So weight is 2 plus 1 plus 2, 2 plus 1 plus 2, then plus 2, and then plus 3, and then plus 1, and then plus 4, and then plus 3. Now the count weight. So this is the cost of, this is the minimum cost spanning tree. So see that this is a tree, right? This does not contain any cycle and also cover the all vertices. Okay, this cover the all vertices, and also it is cover the all vertices, and it have the minimum cost. So by minimum weight we reaches, no, by minimum weight, by which have the minimum we expand with that, which have minimum we expand with that. So this is the minimum cost spanning tree, MCST. And the count is actually exactly whatever the weight have. This is 3, 3 to 5, 5 to 7, 7 to 10, 11, 14, 11, 14, 15. This is 15.
Sir, I have a doubt, actually 2 doubts.
Yeah, what is your doubt?
So we have started from D, then we went up to E, then G, then H, and then I. So when we reach an end, we have to again start from D, like from the starting point, right, sir?
Huh.
Okay. So then we went from D to A.
When you reaches to,
Hello, sir, you are not audible.
Sir, you are not audible.
sorry, what are you saying?
Sir, you are not audible.
Not audible, sir.
Yeah, I'm just audible. Yeah, I'm just listening you. Am I audible right now? Am I audible right now?
Yes, sir.
Oh, okay, just a minute. Let me check.
Sir, there is a glitch.
Is that better now? Am I audible?
Yes, sir.
Okay. Now, so what is the Kruskal? We can do the Kruskal algorithm is that, what is that? Try to go with the minimum weightage, like choose this one, choose this one. Now choose this one. I just choose this one. Okay. Choose this one. Now which have the minimum? Choose this. This is the minimum. Choose this one. So this is the minimum we have. Now accept that which is the minimum. So this is the minimum. So this is the minimum. And now which have the minimum among, after choosing which have the minimum? This is the minimum, right? Now accept that which is the minimum. Which is the minimum? 3 is there. Choose 3. Now among which is the minimum? Now 3 is done. So this is the 3 we have. This is done. Now which is the minimum? Except 3. Now 4 is remain. So if you try to go up this 4, no, this makes a cycle, but we don't want. So you cannot choose this one. Okay. You cannot choose this 4 because it makes a cycle. So you cannot choose this one. Okay.
So
You will have to choose this one. Yes.
So when we chose
Yes.
D2, the D is the starting point, We completed at first we completed till I D E H I, and then again we started at D, and then we went A to A. And why didn't we go to B? Why didn't we go to B? A B. We just
Yes.
stop there and we focus on E. I'm not sure why.
No.
we did
Could you
that.
repeat, please? I didn't get.
Okay, sir. So
Sorry.
from the
Could you
first-
repeat, please? From D to A we reaches. So then.
Then why did we go from A to B? B for boy. Why did we that five? The weightage
B
5.
for
why
why?
didn't we
A
go?
to B. Why I not go with the B, A to B? This is the
Yes.
problem.
Yes.
Because see that the weight is here 5, no, but we want minimum.
Okay. But
This
we
weight
don't have
is
any
5.
other edges.
We
connected
expanded
to-
how? Sorry.
So,
Sorry?
A is not connected to any other edge, but only to B. So here the minimum will be 5, right, sir?
So here is A is not connected with anyone. It is connected with B only. But we want to actually searching a tree, no? We are actually searching a tree. And also if we from A to go, we'll go B here. So this weight is 5, but we are actually searching the vertices by which route we give the minimum. If you go with B, it will give 5, but if you go with E to B, it gives 4. Right? So by this route we will go, or by this route. If you want to reach B, so okay, you want to reach B, but with the minimum cost we want to reach B. So by this route, if we go, it will be 5. But if we go with this route, E to A, E to B, then it have minimum, right? Then it have minimum.
So it need not be continuous, right, sir?
Yeah, it is not necessary that it is you are going like this and then this then continuously. It is not like that. You have to choose such AAGs which have minimum.
So
Which
if
have
it's
minimum.
Okay, if it's maximum, we have to choose the bigger weightage, right, sir?
No. So it is not the maximum case. There is no problem with the related maximum, which is just this here is this problem is for the minimum MCST.
Okay, sir. Thank you, sir.
So this is the Prim's algorithm, and this is the Kruskal algorithm. Which again, I think then maybe all of you got confused. So let me again explain it here. So minimum means we have to choose D, okay, because D is the minimum weight, or either you can choose with this one also. Let's go with the GF. Okay. Now once you choose as G and F, now which have the minimum? DE. So choose D. It is, see that it is in the separate form. It is this edge is here separated from this edge, but don't worry. Once we start counting, no, we'll reach this one or with the different, but have the minimum weight. So if you go now, choose the minimum one. Now minimum one is 2. This one, either this one, any one of the you can choose. Now this we can choose. This is H. Now among choose the minimum one. Minimum is 2 except 2. Now this have 2 or and this one. We can choose this 2. A. Now choose this one. So which have now minimum weight. Now you can choose this 2. This weight, this age. Now choose the minimum one. This is the 3. So right here 3. This is the 3, no? So you can choose this BC. Now choose the minimum one. This is the minimum one. So choose this one. So see, this is separated, but slowly it is connected once it chooses.
Sir, again, I have a doubt, sir.
So what's your doubt again?
Okay, so if when we chose DE as first,
Hmm.
so then our next minimum weightage will be GF, that is 1,
Yes.
right? But
Yes,
we
yes.
chose EH.
Oh, sorry. Why we don't
But
choose?
when you explained, you said after DE we will choose EH.
No. This is Kruskal algorithm.
Oh, okay. Sorry.
This is another algorithm. This is not. This is Prim's algorithm.
Okay.
This is another method. This is another method to find the minimum weight, minimum cost spending.
Okay, sir.
So we can find any method. We can find the answer in any method.
But anyway, we go. This weight will be the same. this may differ, this graph may differ, but this number, once you add that, this will be the
The
same in the both algorithm.
Yes. The default on the answer is same.
By default, the answer will be, once you add that, it will be the same for both algorithm. Yeah, maybe this graph, and once you by this method or by this method, they may differ, but weight will be final weight will be the same. This need to be confirmed.
Sir, I have a question. What if two weights are the same?
Yeah, what?
What
if
if
it is
two
the
weights?
two weight, no, one by one just choose. Like here, this weight is one, this weight is one. So one by one I chooses.
If like in the example that you have, from I to H, it's 2, and from I to D is 4, right? What if both of them were 2? Like I to D is 2 and I to H is also 2. Then what would
Okay,
you
so I to D is 2, I to H is 2. Sorry,
Yeah,
this is also your thing. So
Yeah.
in that case, only one you will choose, because if you choose this both, no. So in that case, it becomes cycle. Right?
Okay.
It will become a cycle, but we don't want. We want a try
For
to find a
example,
tree.
this is another-
So we cannot choose this.
we cannot
Can you
choose.
please
Yes. Yes.
So
So we have to choose such so that it will not form a cycle. It will form a tree.
Okay, sir.
So if you choose the minimum one, it will be this one. So finally we reaches to the our graph. If you count this is the same weight it's actually will get. So this is a Kruskal element. Okay.
Okay, sir.
So by this way, or if you see the question, no, there will be question, no, so the question will be exactly by any way by the Prism or either Kruskal, but what is going to the minimum cost spent? What is the going to be cost, or what is the tree? So similar question we get. So this is all about, I almost covered what I just tried to set that longest path. I'm not covering this one. This is not needed. James Kruskal, BFS, and I'm not covering this one because BFS is not going to ask. But X-score independent set is also, this is not going to ask. So this is the graph coloring, and this is.
So BFS is the shortest path. Right?
BFS is not shortest path. It is for the, actually it is a method and it will give a tree. So as here, this is actually you are trying to search. It is actually analyze. It is for the analyzing the graph. It is actually the analyzing the graph. This is the most important is here, the BFS tree. What is the BFS tree? You may get the similar question. What is, if it is some graph will be given, and from there you need to find the BFS tree.
So we cannot find the shortest path using BFS.
So shortest path is, there is more algorithm is because, but we are not going to discuss. There is because you may very less chance to get the question, the shortest path. Because to find the shortest path, there are 3 methods we have, 3 algorithm we have. And if I will do start, then our session will going to be more longer than. So don't worry, the question will be asked on the shortest path. Only whatever the topics, that's why an important topic, no? Whatever I wrote here, no? This is the similar question you may get from the adjacency matrix, edges graph, vertex edges, graph coloring, vertex cover is important, BFS is important, longer than MCTSC is. Whatever the important topic I just wrote here, this is one. From here you can at least expect one question from these topics. No, and at least from there you can expect one question from these topics. Okay.
Can you tell the
Sir,
major
I have a
topic?
doubt.
Sorry, one by one. Yes. Now. Yeah. One by one. Some girls have speak. So what's your doubt?
Yeah, sir, some of the topics which were there in the syllabus, I was not able to find it in the video playlist, like limit of sequence, limit of function, these topics.
Yes, differentiation, integration, we have not found in the playlist.
So let me just let me search the. Here itself I will give the link. Okay. Let me give you the link. Playlist is where it's there. Just a minute. So course playlist. Let me give here the link itself. This is the all the whole syllabus. Okay? With the tutorials, you'll see some problems there. So you can watch. Let me give the link here.
Sir,
Yes.
in this section B is not included, sir. It is only section A and section C, sir.
Yes, sir.
Section, what is, sorry, section A and B, sorry?
So there is another playlist for the calculus part, sir. Mathematics for data science 2.
So in this, let me check it here. So I think natural exponential is there, logarithmics is there, Terrell's matrix satisfy. Okay. Let me give the another playlist also. There are 2 playlists. Let me keep that also. I think just a minute. In the calculus is not there, no? So let me give it from here.
I have shared, sir. I have shared the link.
Yeah, that's okay. So this is the 2 playlists you can use for the calculus. This is this playlist for the graph theory and all polynomial quadratic, and this playlist for calculus.
Okay, thank you, sir.
Sir,
So,
can you
Mona,
provide any other question papers for us for practicing, sir? Is it possible?
For practicing, I just given, no, I just given the older QP. That's with the answer it is given, so you can check with that. I just given the older QP also. I think it is of the September 2020.
Is there any other QP other than that one?
For the time being, it is at least one QP is for to get the information, but we don't have the older QP to search. Either you can search on Google also. That's only you can get from there.
So
Or
we
we
can
can the idea is enough to hear whatever the QPs we have. It is enough. You can see it here.
so
Sorry.
we can practice similar questions, sir.
Yeah, similar question. Even I will suggest, whatever the graph question, I just cover the topic. No, only just see those topics only. No need to go. MCT is important. Longest path, BFS, vertex cover, graph coloring, and adjacency matrix. Whatever the graph theory question, I just wrote those topics, which is the similar question we may get from in the question paper.
Sir, in which of the topics we can get maximum marks, sir?
Sorry, which other topic?
Which of the topics we can get maximum marks?
No, I didn't get math. Sorry, calculus portion.
Maximum marks.
Maximum marks.
No, sir, for programming.
Maximum mark is
only for programming.
No, I am unable to tell you that what is going to be which topic is going to maximum part, because each topic have the similar marks, means like similar marks like
So for programming,
for each question.
programming, what are the major topics, sir?
So major topic is
programming.
From the programming side is from that functions and set theory and quadratic function, polynomial, and exponential and logarithm. You can get these. This is the major topic. So let me write the programming. For the programming is because you cannot get the question from calculus, no? Means here the set theory, function, quadratic function, okay, coordinate system and polynomial, okay, exponential and logarithmic. These are the topics only. You will see the question from there, and from the graph theory, vertex cover, okay, tree, and adjacency matrix. Okay, only these 3 topics. In the graph, this is not even the longest path, Arthe spot, or MCST, or these are not only the what is I just wrote vertex cover, tree, adjacency matrix. 3 topics is enough. Okay, these are the topics you can see for the programming. These are the major topics. Even the question will be not even the whole QP is on these topics only. Okay.
So similarly for data science.
So similarly for data science, you can include here only in the data science you can include MC ST, longest path for the graph theory, in the graph theory, and also BFS. Okay, this is from graph theory, it is added, and here is you can add calculus. Okay, you can add calculus. That's all.
Sir, would there be a separate paper for calculus or would it be part of this mathematics paper?
It's the same. It is a single paper, not it will be separated. It one QP, only one QP, single QP, you'll get the whole topic. This is for data science, and this separated form QP is for programming.
So total marks for the qualifier is 150.
For 100 marks.
100 marks?
100 marks QP it is. The question paper will be of.
So how much will the weightage for the mathematics be?
For no, so that is I'm not sure about it. I'm not sure about it what it will be. I just roughly explain this idea. This is going to be the whole.
Also, sir, we will be provided a rough sheets.
Yes,
to draw.
Yeah. Whatever the usual way to write the exam, no. The TCS is actually doing that, so you'll get all as the other exams is TCS is doing that. Similar.
So will be provided.
Yes.
Also, sir, one more question. After the qualifier, when we get into the course, what if due to some personal commitments we weren't able to attend classes for just a week or so?
No, I didn't get your question.
So this is not regarding the qualifier exam. This is after the course has started. If we cannot attend for a week or so, we are not able to attend the course. I'm not sure what will happen.
If you are not attending the exam, then I just disconnected. Could you repeat this? Sorry
Yes,
for
sir.
that. Yeah.
This is not regarding the qualifier exam. This is after getting into the course. If you are not able to attend 1 week's course or something like that due to some personal commitments, is there any repercussions for that?
No, there is one thing. If you unable to cover the 1 week, so you just try to cover the next week. Yeah, there is a flexibility, that is if it is a 12-week course, then at least 8 assignment or 9 assignment need to be completed. There is a relief from the 3 assignment.
So if for the next week I can submit the assignment before week or the week after?
No, it is the due date will be over, then you cannot submit. But the next week, for the next week, you can submit your
week's assignment.
And that week is.
But this will be 0, right?
Whatever that is the left part, it will not give. It will not be validated. It is given to be the 0.
Okay. Thank you, sir.
Sir, I have a doubt.
What is the doubt?
Sir, on the web page, it was given that for each compartment, time allocated is 1 hour 30 minutes, sir. So, can we know the classification for data science exam, sir, as it is for 4 hours? So, do we have specific time allotted, or we can start with our own sequence, sir?
Your own sequence. There is no time specific. It is 1 QP and whatever the whole question paper for 1 hour. For at least for mathematics portion, 1 hour will be provided. Oh, sorry, 1 hour 50 minutes is there. Sorry, 30 minutes.
No, sir. For each paper, it is 30 minutes. Sir.
Oh, sorry, 30 minutes. Okay.
30 minutes in each paper.
Okay.
For a programming language, it is 1 hour 30 minutes. Sir. 3 subjects are there, and maths, arithmetic, reasoning, and English. Sir.
Okay.
For calculus, it is 2 hours.
Yeah, please check with the time, no? But yeah, I just explain you about the questions.
Qualify minimum 35% of qualifying, sir, in each subject. So, or we can get overall 45%, sir. For each subject, it is.
For each is 40, for each is 40 and overall is greater than 40.
35. For
35.
each, it is.
Okay.
Is it necessary?
Please check with the cons, like whatever this criteria. I have not remember that what is that criteria. I just with the topics, what are the question, how the question should be, what are the important topic. This is, and this,
Sir,
how
is
the
there any
timing.
suggestion for programming, sir? Is there any better suggestion? What we should do in this short time, sir? What are
Mathematics part I know, and whatever the topics I just suggested, at least you know the topics, you are able to do the questions.
thank you.
Sir, I have a doubt.
What is the doubt?
Sir, can you share the previous year question paper for other subject also? Is it possible for you?
No. For mathematics only I can say. For other subject is I don't know that. I can
Okay.
share only. I have already shared also with the both programming and data science.
Okay. Sir, and is calculator allowed in the examination? Physical calculator?
No, calculator is not allowed. It is a TCS calculator will be there.
Means we can calculate in the computer itself.
Yeah,
right?
it's a computer. Yes.
Okay. Thank you.
Sir,
Thank
I
you
have
so
a
much.
doubt in one question. Can I share in the chat box?
Okay, we're discussing. I don't want to discuss the questions. Okay, you can share. Let me see. If it is easier, then I can discuss. If it is time taking, then I will skip that.
Okay,
Okay, you can post in that.
Sir,
Yes.
this calculus playlist which was just shared. So does it include like all the videos are to be studied? Is this the complete course or some of
Yes,
the
yes.
videos are?
No, all videos, because yes, sequence is there, limit continuity, integration part is there. Yeah, everything.
Oh, because there are 158 videos in this
Calculus.
playlist. Yeah, the one that was shared just now in the chat box.
Okay. Oh. Yeah, they maybe because this is the whole maths and course in this BS degree. That's why it is. Yes.
Okay.
Sir, I have one more doubt. Sir, like qualifier exam is on 3rd of September. So what is the means? When will course start? What is the date of starting the course?
I don't know that. I don't know that. I don't know. You will get everything via mail or via on the website. You can get that. Don't worry with that.
Okay, sir.
Okay, I'm now stopping the session. Okay, it is already the 3-hour sessions. Okay, we'll see when we'll meet on exam. I'll see there to all of you. Okay, I'm just stopping the session. Thank you so much. Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Good night to all of you.
Good night.
Thank you so much, sir.
Thank you, sir. Good night.